is stating what statement is true about the end behavior of the graph function. So we're talking about end behavior of function. Ooh, this is a really nice writing. I'm actually really happy. I don't know why. Whenever I write something nice, I'm really happy. So it's kind of weird. So I have this function. I have 1, 2. This should be a quartic function because it's going from quadrant 2 to quadrant 1. So I know it's some type of quartic function from advanced functions because I have 1, 2, and 3. I have 3 turning points, right? This here turns out 1, turns out 2, and turns out 3, right? So, but we're talking about end behaviors here. So let's look at this. So A here says that f of x goes to, so I'm going to write them in the reverse order. So as x approaches negative infinity, as x values goes to negative infinity, f of x goes to positive infinity. So f of x goes to positive infinity. B here is as x goes to negative infinity, f of x goes to negative infinity. So as f of x, as x goes to negative infinity, f of x goes to negative infinity. C here is f of x is a decreasing function. Is decreasing. And f of x and as x approaches positive infinity, f of x approaches negative infinity. And D states that as x goes to positive infinity, function value f of x equals 8. So this here is my function. If you look at my function here, so it's saying, let's look at this. Let's look at the first case here. As x approaches negative infinity, f of x approaches positive infinity. This here is correct, right? As x approaches negative infinity, so as I'm going towards negative infinity this way, my function is approaching positive infinity. So this here is correct. B here, as x approaches negative infinity, f of x approaches negative infinity. That's incorrect, right? My function here is going up. My y is going up and not down. This here is wrong. C here is f of x is decreasing, and x as it approaches positive infinity here, f of x goes to negative infinity. As I approach positive infinity, f of x actually also goes to positive infinity. So this here is incorrect. And as x approaches positive infinity, f of x equals 8. As you can see, this is way above 8 already, which means this here is wrong. So in this case, A here is my correct answer. As x approaches negative infinity, f of x approaches positive infinity. So A here is my correct answer. Option A is true. That's good. From the graph, we can see the graph goes to positive infinity as x goes to positive infinity, and the values of f of x goes to positive infinity as the x values goes to negative infinity. So they verify what we did here. Function is neither an increasing nor decreasing functions. Over the interval 0 and 2 is decreasing, and over 2 to infinity, the function is increasing here. So again, I like how what they did here, and they separated in terms of decreasing functions. You have a decreasing function from here up to this point. This is increasing, and intervals of decrease would be this one here and this one here. Intervals of increasing would be this one here and this one here. I don't know what the specific points are, but I could basically show you here. And again, D is also false because my f of x here is much greater than 8, right? It doesn't simply just stop here when as x approaches infinity here. So this here, option A is true. So great logic, great solution. And this here is a perfect solution. Great solution and analysis here.